Before we start, I would like to mention that this video has been heavily inspired by the Dutch Green Building Council and their publication Circular Buildings, a measurement method for disassembly potential 2.0. I have put a link to this publication in the description below. Building upon the principles of design for disassembly, which we spoke about in last week's video, the Building Disassemblability Index serves as a key metric for evaluating the circular potential of structures. This is particularly relevant for mass timber buildings, which often utilize modular, prefabricated elements. The index quantifies how easily a building can be deconstructed, allowing for the reuse of its elements and promoting sustainable building practices. The Building Disassemblability Index, also referred to as the disassembly potential of a building, is defined as the degree to which objects can be disassembled at all scales, without compromising the function of the object or surrounding objects. This concept is particularly relevant for mass timber buildings, which offer unique opportunities for disassembly and reuse. The Disassemblability Index takes into account several factors. These include the type of connections, which refers to the method used to join different elements of the building, and the accessibility to connections, which describes how easily the connections can be reached for disassembly. Another factor is independency, which measures the degree to which elements can be removed without affecting others. Lastly, the geometry of the product edge, or the shape or design of the element's edges, may also influence disassembly. The Building Disassemblability Index plays a vital role in promoting circular economy principles in construction, especially for mass timber buildings. A high disassemblability index enables the harvesting of building elements for reuse, aligning with the circular economy's technical cycle. In the case of mass timber buildings, this means that large structural elements like glue-laminated timber beams or cross-laminated timber panels can potentially be recovered and reused in new constructions. Buildings with high disassemblability are more adaptable to changing needs and conditions. For mass timber buildings, this adaptability can significantly extend the building's functional lifespan, making it more sustainable and economically viable over time. Additionally, disassemblable elements simplify maintenance and replacement, reducing long-term operational costs. This is especially advantageous for wooden elements that may require periodic inspection or treatment, ensuring the building remains efficient and well maintained throughout its life cycle. The Building Disassemblability Index is particularly relevant for mass timber buildings due to their unique characteristics. Mass timber buildings often utilize modular, prefabricated elements, and this inherent modularity can enhance disassemblability if appropriate connection methods are used. The index encourages the use of reversible connections, such as mechanical fasteners like screws or bolts, over adhesive-based options, as these allow for easier disassembly. Furthermore, the natural properties of wood in mass timber elements, such as the ability to cut and reshape the elements, can sometimes facilitate disassembly and reuse, further contributing to a higher disassemblability index. To effectively use the Building Disassemblability Index in mass timber projects, it should be applied to all the elements in the building. Architects and engineers need to consider disassemblability from the early design stages, influencing their choices for construction systems and connection details. Documenting the disassemblability of each component can contribute to a comprehensive material passport for the building. Additionally, the index could be integrated into existing sustainability assessment tools, such as the Building Research Establishment Environmental Assessment Method, BRIA, offering a quantitative measure of the building's circular potential. While the Building Disassemblability Index offers significant benefits, its implementation also presents certain challenges. One key issue is balancing performance to ensure that high disassemblability does not compromise structural integrity or fire safety. Additionally, designing for high disassemblability may lead to increased upfront costs, as it often requires specialized designs. The construction industry must also adapt by developing new skills and processes to effectively implement and take advantage of highly disassemblable elements. While the measurement method that has been laid out by the Dutch Green Building Council is great, there are also some notes I would like to add. Nuts, bolts and screws have the same score of 0.8, but they should be evaluated differently, as nuts and bolts allow for significantly more cycles of fastening and unfastening compared to screws. Similarly, interior wall finishes and other on-site processes related to prefabricated modules require a distinct evaluation approach, as their characteristics and impact on disassemblability differ from those of prefabricated components. Properly distinguishing these elements in scoring ensures a more accurate assessment of their circular potential. The methodology could also be further refined by incorporating assessment of material compatibility and the challenges posed by composite structures. Components made from composite materials or those that involve incompatible material pairings can significantly impede disassembly and recycling efforts. Introducing criteria that evaluate the ease of separating such materials would provide a more comprehensive understanding of a building's disassembly potential. All in all, the Building Disassemblability Index represents a significant step towards quantifying and promoting circular economy principles in construction, particularly for mass timber buildings. By focusing on the ease of deconstruction and the potential for reuse, this index not only supports sustainability goals, but also enhances the long-term value and adaptability of buildings. If you enjoyed this video and want to see more, subscribe to this channel.
Stay informed, stay inspired. TimberTalk.